Hello guys, you're welcome to a new series. In this series we are going to discuss concepts, list unanswered questions, and explain real-life applications of a special branch of mathematics which is called the number theory. The number theory is a branch of mathematics that deals with integers. Okay, it deals with whole numbers. By integers I mean the numbers 0, 1, 2, 3, 4, 5, 6, as well as -1, -2, -3, etc. Okay, so for example 1.6 is not an integer. Okay, 13 over 14 is not an integer. So any number that can be written as a decimal point is not an integer. We are going to focus our attention on the set of integers. Now a very special type of integers is called a prime number, which is of utmost importance. Okay, it's called a prime number. Okay, so what is a prime number? A prime number is a number whose divisors are only 1 and itself. So for example, the number 8 is not a prime number because the divisors of 8 are 1, 2, 4, and 8. Right? However, the number 11 is a prime number because the only divisors of 11 are 1 and 11. Now in the ancient times, a great mathematician called Euclid proved that prime numbers are infinite. He proved it in Euclid's Elements, which were a series of books written by Euclid, and he was able to prove that prime numbers are infinite. However, until today, it seems impossible to find a function that will give you the nth prime. There is no such function. There is no explicit function where if you give this function a value of x, the return would be a prime number. Okay? Although prime numbers seem to be very easy to understand, there is no single formula, okay, that can give you the prime numbers. So now why are we so much interested about prime numbers? We are very interested in prime numbers because they serve as atoms in the set of integers. They are the building blocks for all the set of integers. From prime numbers you can find any other number in the set of integers. And why is that? This goes back to the fundamental theorem of arithmetic. The fundamental theorem of arithmetic says that any integer can be written as a unique factorization of prime numbers. So mathematically speaking, if I give you an integer n, okay, an integer n can be written as p1 to the power e1 times p2 to the power e2 times p3 to the power e3, etc. times pk to the power ek. Okay, this is the fundamental theorem of arithmetics, where p1, p2, p3 up to pk are prime numbers, and e1, e2, e3 up to ek are exponents. For example, if I give you the number 220 and you want to break it down into primes, you can do this, and the prime factorization would be 2 to the power 2 times 5 to the power 1 times 11 to the power 1. Notice that 2, 5, and 11 are prime numbers, and this is unique for 220. So 2 to the power 2 times 5 to the power 1 times 11 to the power 1 is only unique for this number, which is 220. Now this is why the distribution of prime numbers became so important, and many mathematicians were interested in finding the formula for primes because they, as I told you, they are the atoms of integers. Now throughout the ages, many mathematicians tried to come up with a formula that can give you prime numbers, but they all failed. Okay, up until today there is no single formula, explicit formula, in which if you give it a number x, you will get back a prime number. Now, from the many formulas that have been given by mathematicians to predict prime numbers, one form stands out, and this form is due to the French mathematician Marine Mersenne, who has developed it. And usually the prime numbers that have this form, they are given a name which are called Mersenne primes. Mersenne primes, relative to the to the French mathematician Mersenne, who gave the formula for them. So what are Mersenne primes? Mersenne primes are all prime numbers that have the following form, which is 2 to the power p minus 1. 2 to the power p minus 1. Okay, so any prime number having this form is called a Mersenne prime, where p in here is a prime number. Okay, so for example, if you put instead of p 2 to the power 2 minus 1, okay, this is 4 minus 1, which is 3. This is a prime number. 2 to the power 3 minus 1, this is what? This is 8 minus 1, 7. So this is a prime number. Now, if you continue, when you reach 2 to the power 11 minus 1, you're going to get an answer which is not prime. So Mersenne prime formula fails. The first failure of Mersenne prime formula would be 2 to the power 11 minus 1. Therefore, the Mersenne prime formula is not a universal formula. It doesn't give you all the prime numbers in the world, right? But it's a formula that has a certain form, and if you give it, prime numbers, you will get an output, and this output, if it is a prime, it's called a Mersenne prime. Now, why is Mersenne prime important? Because the largest known prime number in the world today, which was discovered in December 2020, is a Mersenne prime. Now, the largest known Mersenne prime is given to be 2 to the power 82 million, 2 to the power 82,589,933 minus 1. Okay, and this was discovered in December 2020 with, of course, using a software called GIMPS, Great Internet Mersenne Prime Search, okay, which anyone can use, anyone can download on the computer and, start searching for Mersenne primes. It's called GIMPS, GIMPS. Okay, and this number, which is 2 to the power 82,589,933 minus 1, if you want to expand it, it will contain 24,862,048 digits. So if you want to just write this number, if you want to just write it, it will take you a book for you to write it, and maybe not one book, many different books. You can see it on YouTube. Okay, you can see it in other videos. How much this number is huge. We're talking about approximately 25 million digits. Digits means numbers next to each other. So for example, 123 contains 3 digits. This number, which is the largest prime number, contains about 25 million digits. So prime numbers today remain a myth. There is no explicit function that is able to give you the nth prime. Okay, usually the way that mathematicians use to detect whether this number is prime or not, we have to divide it by all the prime numbers before it to see if it is a multiple of any one of them, and if not, then we say that this number is also a prime. This is a very tedious method, and still we are using softwares and computers to carry the work of searching for prime numbers. We still don't have an explicit formula, like for example 2k plus 1. Give a value of k, then you will receive a prime. So the most important questions that remain to be asked concerning prime numbers are: what is the nth prime? What is the nth prime? Is there any formula that can give you the nth prime, which is very important, and if it is discovered, many advancements would occur in different areas in engineering, computer science, and number theory. Second question is that given an nth prime, can you find the one that is after it? Okay, it's kind of similar to the first question, but it's asked in an easier way. And the third question, which seems the easiest of all, is that given a number x, can you find the number of primes less than or equal to x? And this this function is called the pi of x, which is the number of primes less than or equal to x, to be discussed in later videos. And we're gonna see its relation to hopefully we're gonna see its relation to the Riemann hypothesis, which is a hypothesis still not proved yet. Whenever there is a hypothesis not proved yet, we call it a conjecture. Okay, so a conjecture is a hypothesis that is not yet proved, and there is an institute which we're gonna discuss later on. It is offering $1 million, okay, for anyone who can prove Riemann's hypothesis. Because if you can prove Riemann's hypothesis, you can prove thousands and hundreds of thousands of other proofs, and you can understand the distribution of primes more and more. So we're gonna see this in later episodes. I hope you enjoyed the video, and I will see you soon.